Hey ladies and gentlemen, this is Miss Humbert here, and today I'm going to do our very first notes of Unit 4, which is Learning Target 1. So today we're going to learn about finding and factoring out the greatest common factor. So it's something a little bit different than anything you've done before, but I think you'll get the hang of it. The biggest thing that you need to know is that Unit 4, we're basically undoing everything we did in Unit 3. So we're undoing everything from Unit 3, so the opposite. So, talking about the greatest common factor. So the greatest common factor, or sometimes you'll hear me call it GCF, of two numbers is the largest number that evenly divides both numbers. So it's the largest number that evenly divides both numbers. Well, how do we go about calculating that out? Well, we make a list. Okay, so we have 6 and we have 9. So I'm going to first write out every pair that multiplies to 6. Well, things that multiply to 6. 1 and 6, 2 and 3. Everything that multiplies to 9, 1 and 3, 3 and 3. Now when you guys come to class, I will give you a multiplication chart that will help you make out these lists. But you want to make sure you write out every single factor because you're trying to find the biggest one. So the biggest number that both lists have in common is 3. So the GCF of 1 and 2 is 3. Let's take a look at 8 and 12. So I'm going to multiply everything or write out everything that multiplies to 8 and 12. Well, things that multiply to 8, you always have 1 in that number, so 1 and 8. And then we have 2 times 4. So what I like to do is, as I'm going down the list on this side, I like to just go in numerical order. I try 1, I try 2, I try 3. And I keep going until I know I have all of those lists. And we can talk about more what that means in class. Well, let's take a look at number 12. So we have 1 and we have 12. Well, 2 divides 12 also, so we have 2 and we have 6. Well, 12 divides 3, or 12 divides 12, or 3 divides 12, there we go, and we get 3 and 4. I need to wake up. All right, so I want to find the biggest number that both of these have in common. Well, I see the biggest number that both lists have in common are 4 and 4. It doesn't always have to be in the right column. It just needs to be a number that multiplies to each of those numbers. Okay, let's take a look at 5 and 10. So I'm going to write the things that multiply to 5 and the things that multiply to 10. Now, some of you might be able to do this in your head, and that's great. If you want to do that, you can, but here's what I'll tell you. The more work you write out, the more I can think inside of your head. You can show me your work. Well, here I notice that the biggest number these two lists have in common are 5. So the greatest common factor of 5 and 10 is 5. Well, let's take a look at 2 and 7. So we have 1 and 2, and for 7 we have 1 and 7. So technically, our greatest common factor would be 1. But 1 actually isn't a common factor because if I divide 2 by 1, it doesn't change 2. So if the only common factor they have is 1, then we say that this has no GCF. So there's no GCF for this one right here. Okay, let's take a look at when we're talking about variables here. The GCF of two variables is the variable with the lowest exponent you see among the terms. So not only that, but it has to be in each term. Okay, so it's the variable with the lowest exponent. That's what you can take. Because think of it this way. We want to take the same amount of x's out of each term. Well, if the smallest amount of x's we have is x squared, I can't take x to the 5th out of x squared. So when we're looking at number 5, between x to the 3rd and x to the 5th, we want to pick the one that has the smallest exponent. And that's going to be x to the 3rd. So the GCF, or the greatest common factor of number 5, is x to the 3rd. Same thing with number 6. We want to look for the smallest amount of letters, or the smallest exponent is y squared. So the greatest common factor of y squared and y to the 7th is y squared. Now let's take a look at some examples that might be a little bit more complicated. So for this one, we need to do two things. We need to find the GCF of the coefficients and figure out how many x's we can take out. So we have 10 and we have 15. So for 10, I have 1 and 5, or sorry, 1 and 10, 2 and 5. For 15, 1 and 15, 3 and 5. So the greatest common factor between 10 and 15 is 5. So I'm just going to write that down there. Then we also have this x squared and we have x to the 3rd. So I want to look for the smallest number of exponents, and that's going to be x squared. So 5x squared is our final answer for number 7. That's our greatest common factor. So we're starting with finding. We're going to start factoring them here in a second. Well, let's take a look at 3 and 5. So we have 3 and 5. Well, I have 1 and 3 and 1 and 5. So the biggest number I can take out is 1. Okay, so that's really not taking out a GCF, but if you want to write the 1, you can. Then I look, here I have x to the first and x squared. Well, the smallest exponent of x's that I have is x to the first. So the GCF between those two terms is 1x to the first. Okay, so now that we've figured out how to find the greatest common factor, we want to go through steps on how to actually factor it out. So the first thing you need to do is find the largest number that divides each coefficient. Okay, that's what we did on problems 1 through 4. Then find the exponent of the variable. That's 5 and 6. Again, you need to make sure that that exponent is in every single term. All right, then you're going to divide each of your terms by the GCF. That's where stuff from Unit 3 is going to come in. And then you're going to write out your new polynomial as being multiplied by the GCF. So eventually, when you're done, you're going to have something that looks like this. You have your GCF on the outside, and then you have your polynomial on the inside of the parentheses. So let's go ahead and take a look at number 9. So we want to start by taking a look at 12 and 16 and seeing what multiplies into those. Well, we have 1, whoa. So for 12, we have 1 and 12. And we have 2 and 6. And we have 3 and 4. So that's it for 12. For 16, we have 1 and 16, 2 and 8, and we also have 4 and 4. So the largest number that both of these have in common then is going to be 4. I see that my smallest number of a's is a to the first. So now I'm going to go ahead and I know that my GCF is 4a to the first power. So here's where Unit 3 comes in. I'm going to go ahead and I'm going to divide each of these terms by 4a. So let's do it term by term. 12 divided by 4 is going to give me 3. So I'm going to write that on the inside of my parenthesis. A squared divided by a to the first. Well, we subtract those exponents. 2 minus 1 is 1. That's going to give me a to the first. Or you could just write a. Here, 16 divided by 4 is just 4. And a over a is actually going to cancel out completely, so we don't have any a's. So 4a times 3a plus 4 is our final answer for number 9. Next, let's take a look at number 10. So we need to figure out what multiplies to 14, what multiplies to 6, and what multiplies to negative 4. Don't necessarily worry about the negative, focus in on the 4. So here we have 1 and 14. 2 and 7. If you're not seeing how I'm making these lists, go ahead and pause your video and come work with me directly so I can help you kind of figure that out. I'm assuming most of you can figure out the factors of these numbers. So the largest number that each of those 3 lists have in common is 2. So I notice I have r cubed, r squared, and r to the first. So the smallest number of r's I have is r to the first. So my GCF for that is 2r to the first. Now I need to actually divide that GCF out. So I'm going to take and divide each term by 2r. Okay, so 14 divided by 2 is going to give us 7. Here we have r cubed divided by r to the first. Well, 3 minus 2, so that's going to give us 7. 3 minus 2 is going to give us r squared. Next, 6 divided by 2 is 3. R squared divided by r to the first, that's just going to leave us with r when you subtract those exponents. Negative 4 divided by 2 is going to give us negative 2, and those r's cancel out. So this right here is your final answer for number 10. Okay, moving forward, let's take a look at number 11. So first we want to make our list for 5 and 30. So we have 1 and 5. For 30, we have 1 and 30. Next, I'm going to try 2. Well, what multiplies by 2 to get to 30 is 2 and 15. What also multiplies to 30? 3 and 10. Does 4 go into 30? No, let's check 5. Well, 5 does, and we get 5 and 6. So the greatest common factor between 5 and 30 is 5. Now I see that I have an x in this term, but I don't have an x in that second term. So that means I can't factor out an x. I see that I have a y in this term, but I can't factor y out of that term. If you can't take it out of every single term, you can't take it out at all. So there are no letters that we can take out. So we're just going to take out a 5. So I'm going to divide each of these terms by 5. 5 over 5 is just x. 30 divided by 5 is 6, and then we have that y. So this is the same as 5 times x plus 6y. So let's take a look at number 12. So we need to figure out what multiplies to 12, what multiplies to 3, and what multiplies to 9. So for 12, we have 1 and 12, 2 and 6, 3 and 4. For 3, we have 1 and 3. For 9, we have 1 and 9, and 3 and 3. So what goes into each of those lists? This, this, and this. 3 is the biggest number that goes into this. Now, a lot of students think, they say, hey, Miss Humbert, our lowest exponent is x to the first power. So we're going to take out x to the first power. Well, that's not true. This 9 right here doesn't have an x term. So because it doesn't have an x term, we can't take x out at all. So the only thing we can do is divide each of these terms by 3. So we're going to divide the coefficients. 12 divided by 3 is 4, and then we're going to keep x squared. 3 over 3 is just going to be 1, so I'm just going to write x. You could write 1x if you wanted to. And negative 9 divided by 3 is negative 3. So this right here is your final answer. 3 times 4x squared plus x minus 3. Next, let's take a look at number 13. So we're going to write out those factor lists. So we have 4 and 12 and 8. So we have 1 and 4, 2 and 2 under the first one. For the next one, 1 and 12, 2 and 6, 3 and 4, that multiply to 12. And for 8, 1 and 8, 2 and 4. So now we want to go through and we want to figure out the biggest number they have in common, which is going to be 2. So 2 is the biggest number that each of those have in common. And then I see I have x cubed, x squared, and x to the first. So that means I can take 2x to the first out. So I'm dividing each of these terms by 2x. 4 divided by 2 is 2. X cubed divided by x to the first is x squared. 6 divided by 2 is going to give me 6. X squared divided by x is just going to give me x. Negative 8 divided by 2 is negative 4, and my x's are going to cancel. So this right here is my final answer for number 13. Next, let's take a look at number 5. So we have 5, 15, and 20. So for 5, we have 1 and 5. For 15, 1 and 5. 3 and 5. For 20, 1 and 20. 2 and 10. 4 and 5. Again, if you're still struggling to make those lists, let me know. So out of each term, I can take out a 5. The smallest number of x's I have is that second, so x to the second. So my greatest common factor is 5x squared. So I'm dividing each of these terms by 5x squared. So 5 divided by 5 is just going to be 1. X to the 4th divided by x squared. 4 minus 2 is 2, so that's going to leave me with 2x squared, or you could write 1x squared. Negative 15 divided by 5 is going to give me a negative 3. X cubed divided by x squared, 3 minus 2 is 1. 20 divided by 5 is 4. X squared over x squared is going to cancel out. So this right here is your final answer for number 14. So that concludes your note video. Go ahead and show me your completed note sheet when you're done. Thanks for listening.